now talking about a tech talk on Openstack for Future Technologies. We have with us our speaker, LR Prakash, Senior Director, C-DAC. LR Prakash is a graduate of the National Defense Academy and the Naval College of Engineering. He obtained an MTech in Microwave Signals and Systems from the IIT Kharagpur. He was an electric engineer officer in the Indian Navy and was associated with projects in signal processing, instrumentation, and electronic design. He has a wide range of interests in AI, networking, and security. And he took over as a senior director, C-DAC Chennai, in May 2014. So ladies and gentlemen, now it is time to call upon LR Prakash on your screen. Over to you, sir. So requesting you to kindly unmute yourself, please.
So, good morning.
Yes, and also if we could have your video on, please, sir. If you would like your video on.
Yeah, I just shared my presentation.
Yes, I can see your presentation. Thank you so much, sir.
Fine. Yeah. First, our sincere apologies that our Senior Director, Commander LR Prakash, is in another call and he will be joining us shortly. So myself, Kailash, Joint Director, C-DAC Chennai, will take over the session and he will join us for the discussions. So, good morning all the participants of World Cloud Show. So in this session, I shall provide the overview of OpenStack and its scalability to meet the demands of future technology that sits on top of a cloud environment. So the agenda of my session is that first I'll just give a gist of what is OpenStack and OpenStack Foundation, the community that manages and controls the development and release of OpenStack, certain future technologies that cloud is getting transformed in a way, and the scalability of OpenStack to meet such transformation. And finally, just of C-DAC and collaboration with OpenStack Foundation. So OpenStack is a open source, free and open source cloud operating system with a massive deployment of public, private, or hybrid kind of cloud environments. And it is one of the top 3 most active open source projects. So as on date, open source component of OpenStack is trusted to manage a cloud environment with around 20 plus million cores around the world. So OpenStack is an open source cloud OS. So what does it mean is like you take OpenStack and it offers a comprehensive features and functionalities to establish your cloud environment. So OpenStack is, as I said, completely open source with the principles of open design, open development by an open community. So as far as open design is concerned, for every development lifecycle, the OpenStack community events are open to anybody to gather the requirements, write the specification for upcoming releases. So this participation can be by generic users, developers, or the core community members. And open development is that the source code repository is publicly available through the entire development process, with the code reviews being done by public along with the suggestions for roadmaps and all that. All sort of suggestions are welcome by the general public also. And all the lifecycle process is completely documented. It is open and transparent. So this OpenStack is broken up into multiple services that allows you to plug and play the components depending on your needs. So you can customize your environment. You take a comprehensive set of features, functionalities from OpenStack, customize each and every features, and you can deploy it as per your organization business goals. So beyond like a standard infrastructure as a service functionality, it offers additional management components like orchestration, fault management, service management, and ensuring high availability of user workloads. So all these components are in a plug and play fashion, where you take a common OpenStack functionality to offer infrastructure service. Along with that, you integrate a fault management or a service management component or an orchestration component, enhance security mechanism, or ensure high availability. So all this can be customized and configured in a OpenStack cloud environment. So the design goals of OpenStack is that first goal is on data center management. So it provides the abstractions needed to deal with external systems like compute, storage, and networking, the data center IT components, along with the other functional components like domain DNS systems, identity management systems. So OpenStack APIs provide a consistent interface to these kind of data center management systems, which may be potentially implemented by various vendors or can be integrated with other open source projects. So it play well with others. So OpenStack supports and encourages extreme layer of abstraction, including platform service, serverless compute platforms, container orchestration engines. So between itself and the end user applications. So this run with the compute capacity that it can provision. So hardware virtualization, the complete virtualization process is controlled by OpenStack specific software, so which leads to software defined control of allocating the resources completely in a multi-tenant environment. So continuous scaling. Here OpenStack tries to provide application developers with interfaces that allows them in principle to scale effectively from very small to very large workloads without re-architecting their applications. This means that allowing customers to use the capacity as needed and share underlying resources and services with other tenants in case of a multi-tenant environment. So along with that, it offers built-in reliability and durability. So the process like high availability is being ensured while deploying your workloads on top of a OpenStack environment. So it aims to provide primitives that allow developers to build a reliable applications on top of it. OpenStack does not impose any particular deployment model or architecture or applications. So it does, since it follows open APIs, this can be extremely scaled up to any mode of you operations, and all the resources and service workloads are being controlled through a graphical user interface. So the OpenStack Foundation was established in OpenStack. The first version was released in 2010, and then it has been revamped with various or scaled up with various advancements by the OpenStack Foundation. So till date, 21 on-time release, so which are being named in an alphabetical order from Aston to Uzuri. So initially it was started with two projects. There is two projects for controlling two functionalities, like for example, compute and storage or compute and network. So all this features and functionalities are termed in as individual specific projects. So as on date, OpenStack supports 42 projects, which means that 42 features and functionalities are being supported. So there are almost like 5 lakh changes being merged and 8,000 plus individual developers authorizing the changes. So the changes can be done by any contributor to the OpenStack component or by the contributors from OpenStack Foundation. And these are being perfectly reviewed and authorized for commit. So every day almost 900 changes are proposed, since there are 42 projects starting from the management of storage, compute, networks, security, orchestration, so other added services like data analytics sort of stuff. So there are 900 changes that are being proposed every day, and 18,000 tests are being run to evaluate these changes. So now OpenStack Focus is solving the problems that occur at the infrastructure level for hosting the modern use cases. So the underlying conventional cloud infrastructure should cater the demands of modern use cases, which includes continuous integration, CI/CDs, edge computing, hybrid clouds, containers, artificial intelligence, and machine learning environments. So such infrastructure is to be effectively managed and orchestrated with high level of automation as you go for a large massive scale deployments with the modern use cases. So this OpenStack Foundation focus on providing solutions to cater the needs of this upcoming or modern use cases through its various projects. So one among them is Airship. So Airship is a collection of loosely coupled and interoperable open source tools that automate the cloud provisioning. Starting from a raw bare metal infrastructure, this Airship manages full life cycle of data center infrastructure to deliver a production grade Kubernetes cluster. This combines the most popular virtualization platform with most popular container platform, that is OpenStack with Kubernetes. This allows operators to manage their infrastructure deployments and life cycles through declarative YAML documents that describes the complete Airship environment. So expanding the software stack is quite simple because a single workflow may be executed for managing both initial installations and updates. So inbuilt TLS enabled service endpoints and encrypted storage make this secure platform across entire data centers. So the use cases for Airship includes traditional cloud workloads, starting from infrastructure service, platform, or other software services and upcoming cloud-based workloads, containerized CI/CD environments, along with that is being bundled or integrated over OpenStack virtual machines. So this provides a Kubernetes environment allowing tenants to create containerized network functions when you are implementing advanced networking methodologies like NVF kind of thing. So this containerized network functions comes into picture, and that is being offered through Airship. The next upcoming component that gets integrated with OpenStack is called Kata. So it's a secure container runtime environment with lightweight virtual machines, so that feel and perform like containers, but provide strong workload isolation using hardware virtualization technology. So to the existing containers, additional isolation is brought in. So that is brought in using the conventional hardware virtualization technology. So this acts as a second layer of defense to your containers. So Kata containers integrate with container management layers, including popular orchestration tools such as Docker, Kubernetes, while delivering the security advantages of VMs. This supports industry standards, including OCI, Open Container Interface Format, and Kubernetes Container Runtime Interface formats. Some of the features of Kata are that it runs as in a dedicated kernel, providing isolation at a network, IO, and memory level, and can utilize the hardware enforced isolation with virtualization VT flag extensions. So deliver a consistent performance as standard Linux containers with increased level of isolation. And it eliminates the requirement of nesting containers inside the virtual machines. So standard interfaces make it easy to plug in and get and start the rollouts. The third most important component is called Starlink X. So it is the edge cloud infrastructure to offer a high performance and ultra low latency applications. So the complete cloud infrastructure software stack for the edge, which is being used by most demanding high performance applications in industrial IoT, telecom, video delivery, or other ultra low latency use cases. So all that is being managed or supported by this Starling X project. So it offers fault management, fast, secure VM failover and live migration, thereby which minimizes the downtime of your workloads. So it is deployable on 1 to n number of distributed nodes, allowing a single system to be used from the edge environment to the core cloud environment. So it provides a platform for edge and IoT use cases, even for environments with tight resource constraints. Tunable performance can be optimized for certain specific use cases. So the a high level of security is being offered, which ensures that tampering is avoided at the edge nodes, where the physical security may be limited. So edge nodes are the computational units that is being placed at the close proximity to the source of data or source of like a computation. So the simplified deployment and operations with full system management through comprehensive orchestration, which is suited for the edge, as being ensured by the Starling X component. So the next component is Zool, which drives continuous CI, CDs, and deployment systems with specific focus on project gating and interrelated projects. So project gating is that it keeps your builds in the repo evergreen by automatically merging the changes only if they pass certain tests. So as I said, integrated with CI/CD components like Ansible. So it also supports cross project dependencies. So where you can easily test changes to multiple systems together before landing onto a single patch. The OpenStack infrastructure team is set to build Zool, which could parallelize the serial testing of OpenStack. Initially, it was coordinating only Jenkins and later replaced with Ansible to improve performance and reliability. One initiative from this foundation is something like Open Infra Labs. So Open Infra Labs is a community of infrastructure providers and operators. So the main focus is on integration testing of all components necessary to provide a complete use case. So this integrate and optimize open source projects in production environments and publish a complete reproducible stacks for existing and emerging workloads. The primary objective of this lab is to deliver open source tools to run your cloud, container, artificial intelligence, machine learning, edge workloads. So repeatedly, so which means that wants to deliver a common platform to run all these workloads along with their applicable scenarios, like sample applications that use these workloads. So it also has a shared code repository for cross-layer optimization and operational tooling with the glue code that is generally being written written independently by the users or contributors to the OpenStack. So the OpenStack next focuses on high performance computing, which provides the solutions for the challenges of delivering a flexible infrastructure for high performance computing and high throughput computing workloads. So OpenStack is used to provide infrastructure as a service to end users, along with enabling them to dynamically create an isolated HPC environments with a level of orchestration on this dynamically created HPC environments. So this is highly suitable for modern HPC applications or services with with a level of native cloud integration, wanting to make use of such OpenStack cloud services. So this is OpenStack is optimized for large batch jobs or individual research environments with a massive compute and storage requirements or network requirements. So one such deliverable from this is artificial intelligence or machine learning platform as a service. That is like AI-enabled HPC environment is being offered as a service. Apart from that, it also one other deliverable is that a software-defined cloud storage, which has a self-healing, self-managing platform, providing redundancy and scalability. So the features and functionalities are that software-defined automation is brought in across all the layers. Flexibility to optimize large batch jobs. So and general purpose management framework for the GPUs, GPAs, and SSDs and ASICs. So C-DAC Chennai is the authorized consultant, integrator, and training partner of Openstack Foundation in the Asia Pacific region. So as a part of the consultant and integrator, we offer the consulting, system integration, management, operations, support, development, and customization of OpenStack. And as a training partner, we offer certification programs like Certified OpenStack Administrator as a basic course, integrator in the intermediate, and solution architect as an advanced course. C-DAC Chennai is a nodal center for national free and open national resource center for free and open source software (NRC FAS). So as a part of that, C-DAC Chennai has come out with a solution called Meghdut, which is a integrated free and open source offering for implementation, management, maintenance, and operation of a cloud environment. So this ensures a high degree of customization and enhancements. Like this is a comprehensive suite with various free and open source softwares across all layers, like virtualization, security, management, monitoring. So at all the standard layers of cloud, Meghdut constitutes various free and open source tools along with our value additions to this, and that is being offered as free and open source suite to the end users. So it means that you can deploy your own cloud environment with this suite. So and this can be highly extended to offer value added services, since this is based on OpenStack and open APIs are being ensured. So as I said, we establish the cloud environment, development of cloud features and functionalities, consultancy services. Also, we offer corporate trainings, and our services includes management, maintenance, and operation of a cloud environment. So with this, I'll conclude my session, and I'd like to extend my sincere thanks for the organizers and the participants. So any questions or clarifications or discussions, please?
Sure. Sure. Thank you so much for your time. We would have loved to even e-meet LR Prakash, but I'm sure that he's a little caught up right now. But thank you so much on behalf of Trescon for joining us today, sir.
Yeah, thank you.
Thank you.